Hello, everyone. My name is Chris Kuo. I'm currently the Chief Information Security Officer of Acer Cybersecurity Incorporated. Today, I'm going to share some of our experience of industrial environment infrastructure protection and OT security. First, I'll talk about the CI and OT basics, and then I'll explain some of our experiences of OT security projects. And eventually, I will have a brief conclusion for you. ACSI is the largest MSSP in Taiwan. That is the managed security service provider. And we are also the first IPO of MSSP in Taiwan. Our security operations center has over 150 clients, and we monitor over 6,800 security devices, including firewall, IPS, WAF, and antivirus systems, and AD, and so on. We also provide security vulnerability assessment, penetration testing, APP security verification, denial of service testing, and ISMS and PIMS as consulting services. The critical infrastructure in Taiwan actually was specified totally 8 sectors by the government, including finance, energy, water resources, and transportation, healthcare, telecommunication, high-tech science parks, and government agencies. So within these 8 sectors, there are 4 heavily related to industrial control systems, including energy, water resources, transportation, and high-tech science parks. Once there are incidents occurred to impact those critical infrastructure, actually the national security, economy, human life, or even environment will have serious consequences. So critical infrastructure is very important, so we have to pay attention and protect them. The OT environment actually have layered structure, including level 0 are the field instrumentation, including various devices here. And level 1 is the basic process control. And level 2 is the area supervisory. And level 3 is the site manufacturing operations. And from level 0 to level 3 are the OT environment. So inside this OT environment, actually there are a lot of devices and systems deployed, including sensors, remote terminal units, programmable logic controllers, data acquisition systems, distributed control systems, and supervisory control and data acquisition systems. So level 0 to level 3 are OT environment. And level 4 are site business planning, and level 5 is the enterprise network. So level 4 and level 5 are the IT part. So within this structure, between the OT part and the IT part, there may be DMZ area here. So once there are data to transfer from the OT environment to the IT environment, the DMZ is used as a buffer to transfer the data, and so that to protect the OT network from direct access from the IT network. And the priority of the OT environment actually is quite different from the IT environment. Safety is the priority 1 to be considered, because once the OT networks have some incidents or some problems, actually there will be serious consequences, including explosion or gas leakage or this kind of bad things. So human life may be threatened. So safety is the most important. And availability is the second important, because most of the OT sites or the factories, they are 7/24 and they operate year-round. So availability is also very important. And then is integrity and confidentiality. So this priority actually is quite different from IT world. ACSI has executed more than 10 OT security projects for energy, water resource, and transportation sectors. we have conducted several ICS security baseline conformance consulting services for our customers, including a risk assessment for their OT environment. And we also have provide OT network segregation testing for the customers to see if there is any chance to access the OT devices from internet. And we also built several OT security intelligence sharing platforms for our customers. So these customers have the need to share security intelligence with others. So we have built several platforms for the customers. And also we provide OT security health checking services. And this checking actually is closely related to the risk assessment we provided here. And finally, we also build OT SOC for our customers. And we have two pilot projects completed. I will talk about later. And for the security intelligence sharing, actually in Taiwan, there are layered structure as I showed here. The upper layer is the nation level. So the executive yuan, the highest administration agency in Taiwan, actually runs the NISEC. And for the sector level, for example, the energy and water resource sector, these two are governed by Ministry of Economic Affairs. So we have built for MOEA, the EISEC platform to share the security intelligence. And for the critical infrastructure provider level, actually we have built 5 ISEC platforms for Water Resource Agency, for Taiwan Water Corporation, and for CBC Corporation. This is a petroleum refinery and supply company in Taiwan. And for Thai Power, which is a power supply company. And also for Bureau of Energy. This agency is the governing agency of the private sector energy companies. So totally we have built a bunch of EISEC platforms to share, to exchange the security intelligence. And we also help MOEA to develop the ICS security baseline. As I mentioned earlier, that actually the OT world and the IT world, they have different priority. So the security baseline for IT systems actually is not applicable for OT environment. In this security baseline, actually we have established 10 phases, including access control, audit and accountability, BCP, INA, and system and communication protection, and so on. So in each of the phase, we have built some of the control items and more controls. For example, for the access control phase, we have 4 control items and 15 controls. The 4 control items include account management, least privilege, remote access, and network architecture and segregation. So we also conducted the baseline conformance test and review for some of the sites. Take this one, for example, we have provided the baseline review for several dams in Taiwan. And the target are the critical control systems in those dams. And as you can see the result here, for example, the dam 1, for the 34 control items, the conformed are 31 items, and 3 of them are partially conformed. And for dam 2, actually, there are some items that are non-conformance. So for those partially conformed and non-conformed items, we provide suggestions and improvements for those sites to consider so that they can do something to remediate those non-conformance. And in the water resource sector, we have conducted for 18 dams and weirs the asset inventory and risk assessment service. So we will go to the site and review their assets, and we will complete an asset inventory list. And also we will do the assessment and inspection of those industrial control systems. And we will also review one by one of their network devices. So there are quite a bit of issues found during these processes, including a performance issue of environmental control system, expired UPS, and lack of device checking and verification, and some outdated Microsoft products and IoT devices install unnecessary softwares, insufficient backup of system and data, and so on. And for the internet exposure test, actually we have conducted for a bunch of sites here, including 6. And as we can see that we do the test from internet, and we found several problems, including the OT devices use default password. And also the device may expose ICS brand and type, and expose ICS protocol, and open the remote desk service, and expose network device management interface, and expose services. So we take a site A, for example. Actually, there are quite a bunch of problems we have found. So totally, there are 129 threat vectors that can be used by hackers to access the OT devices. So this is high risk. So we have provided suggestions and help those sites to fix these threat vectors. And for the first line OT SOC and second line OT SOC, you can see in this diagram, this is the OT network. And we have built the industrial IDS system inside the OT environment. And we collect network packets from the core switch, use mirror port. And those logs collected will send through a one-way channel to the industrial DMZ. And here we have a security event collector which collect all those logs and do the filtering works, and then send the results to the OT SOC. This is the first line security monitoring mechanism. And once the security rules are triggered, and there will be security alerts issued, and these security alerts will send to the second line SOC for long period analysis. So in 2020, we have 2 pilot deployments for a water dam control system and a ship positioning system. Finally, I will have a brief conclusion. Critical infrastructure and OT are becoming risky. Take one example in 2020, one major petroleum refinery company in Taiwan had been hit by a ransomware and causing over 7,000 Windows platform locked. So this is a serious incident and caused the service interruption of this company. And we have accumulated a lot of experience from past OT security projects. And actually, we are now focused on some other items and issues, including the OT security compliance audit. This is one of the focus in this year's project. And also, we will do the OT security real case attack and defense exercise. So we will design these exercises in the OT environment, and we will have the attack scenario and defense scenario designed for those OT personnel to learn. And finally, we will conduct OT security training. Before we do the training, actually, we will develop the roadmap, and we will design the courses so that the OT personnel will have more sense about security. And if they are well trained, actually, the OT security level will be raised. This is all my presentation. Thank you.